Hello everybody, welcome back to PHS Maths. We got quite a fun geometry problem today. Before we start though, a little bit of Welsh for you. The Welsh for small circle is a cylch bach, cylch being circle and bach being small. If there are any Welsh words you'd like to know, feel free to ask about these in the comments below. Okay, let's get on with today's problem. Problem. Find the exact radius of the small circle. You can see here the small circle is red. It touches both the x and y axes, and it also touches a larger blue part of a circle that you can see on the picture. If you'd like to have a go at this problem on your own, pause the video now. Hint. I've got two hints for you today. The first hint is to copy this diagram out and to draw some useful lines on it. Now this question asks us to find the small radius, so it certainly makes sense to draw one or more of these radii on our picture. The second hint is Pythagoras' theorem. This might well come in handy in this problem. So a quick recap, Pythagoras' theorem states that for any right-angled triangle with shorter sides A and B and longest side or hypotenuse C, it is true that A squared plus B squared equals C squared. If you'd like to have a go at this problem using these hints to help you, pause the video now. Solution. As I mentioned, the first thing to do is to draw some useful lines on our diagram. Firstly, these radii for the small circle, and this extra diagonal line A. You may also notice this shape in the bottom left corner is a square. From this picture now, I can write down a couple of useful equations. The first equation is A plus R equals 10, because you can see that the radius of the larger blue circle, or in this case quarter circle, is in fact 10. I can also write down, looking at the triangle within that square, that r squared plus r squared equals a squared using Pythagoras' theorem. Simplifying that, I can write 2r squared equals a squared, and then I can square root both sides to give me root 2r equals a. Now that's useful because now I've got a equals something, I can substitute that as a into the first equation, which gives me an equation with just r and no a in it at all. So I can solve this. To do so, I need to take out a factor of r. So the r goes on the outside the brackets. R times root 2 gives me the root 2r, so I've got root 2 first on the inside. And r times 1 will give me the r. So that means I've got r root 2 plus 1 equals 10. To solve for r, I just need to divide by this bracket to give me r equals 10 divided by root 2 plus 1. I'm not going to type this in the calculator to give me a decimal because the question asked me for an exact radius. So this is an exact radius of the small circle. One thing we do often like to do though is to rationalise the denominator. And don't worry if you've not met this before, it basically means we don't like these square roots really being left on the bottom of fractions. So a little trick for this in this case is to multiply by root 2 minus 1 on both the numerator and the denominator of the fraction. So the top we've just got 10 bracket root 2 minus 1. The clever thing is on the bottom we end up with root 2 times root 2, which is 2. The two middle terms cancel, so I've just actually got 2 take away 1, which is just 1. So the final answer comes out as 10 bracket root 2 minus 1. But like I said, the other answer is still mathematically correct, so don't worry if you weren't sure how to rationalise the denominator yet. Okay, I hope you enjoyed today's problem. Feel free to share any ideas in the comments below of any topics you'd like me to cover. Make sure to like and subscribe, and I'll see you in the next video.